Hi everyone. In lesson 8.3 today we're going to be learning how to solve a quadratic function but using our calculator and graphing it in our calculator. Okay, so let's just briefly look through the steps. First, knowing that the word solutions also means x-intercepts. Okay, it's important to note that solutions means many different things. I'm going to write them over here. It means x-intercepts, okay, roots, or zeros. They all mean the same thing. So when I ask you to find the solutions, like when you are factoring, you've been factoring and finding those solutions for 2 days now, at least. And what you were really finding were the x-intercepts. But we can also find those by graphing. So the first thing you do is make sure that your equation is equal to 0. That is very important. So an example, this one here on the left, I need to add 14 to both sides so that there is a 0 on the left side. Okay, now keep in mind you cannot add 14 to 9x because one of them has an x and one doesn't. So it's just going to be written as negative 9x plus 14. And from there, you can type it in your calculator. Now keep in mind, when you do type it in the calculator, you type it in without the 0, equals 0 part. So you can see here on the actual graph that I did not type in the equals 0. Okay. Over here on the right in the bubble, it teaches you how to zoom on your calculator if you need to zoom in on the graph, if you can't see the entire graph, or you can't see the x-intercepts. Where are they? Where is it touching the x-axis? And then using how to use trace for it to tell you exactly where those x-intercepts are. I'm going to show you how to do it now on the calculator, but if you get stuck, go back to this front part of your notes and follow the steps. So let's look at an example on the back. Turn to the back and we're going to look at part 1, the first example. So lucky for us, it's already in standard form where it equals 0. Remember, this first part before the equal sign is what you're going to type in the calculator. So go ahead and get your calculator and go to graph. Okay, I've got my equation plugged in. If you haven't already, maybe you want to pause the video and type it in real quick. Notice I did not put the equals 0. And now I'm going to hit enter to see the graph. All right, so now that it's graphed, I want to see exactly where are the solutions. Now, solutions before were just a number, but now it actually represents something, an x-intercept. In this case, our graph touches the x-axis twice. So let's find out where those are exactly, because they may not always be whole numbers. Select menu, go to number 5 for trace, and number 1 for graph trace. Notice a lot of times it starts way up here. It's starting on the y-intercept for some reason, 0, 20. And we're going to use the arrow keys on our mouse pad at the top to go left and right until we get to our intercepts. For me, I'm going left until that little X is on top of my intercepts. Oh my goodness, look, it even says the word 0. That is our 0 or our root. Another word is solution. One of our solutions is -4. Keep going until you get the other. Our other 0, otherwise known as solution, is -5. So let's write those down. One of our solutions is -4. The other solution was -5. Keep in mind that not all parabolas, like the one we just saw, touch the x-axis twice. Sometimes they may only touch the x-axis once. Some, it may not even touch the x-axis at all, and there may not be any solutions, and you might have to write no solution. So let's look at another example, maybe this one here in the middle, okay? And this one, you'll notice it is not in standard form already, so we have to get it in standard form. So I'm going to minus 5x on both sides, and I'm going to minus the 3 on both sides. Why am I doing that? Because they both need to go away, remember? 5x minus 5x is 0. 3 minus 3 is 0. We don't want anything on that side. We want a 0 over there. Now remember, all of these things on the left, None of those can actually be subtracted from each other. They're all not like terms. One of them's an x squared, one is an x, and one is a constant, and none of them can be combined. So write it like you read it. What's first up there? 2x squared. Then a minus 5, and then a minus 3. Now it is in standard form, and I can type it in the calculator to find the solutions. If you have not typed it in, maybe take a moment to pause and type in the equation into graph. I'm going to hit enter. There it is. Now you might think this is at 1, -1, and 3, but make sure you double check that it is a positive, that they are whole numbers. They may not be. So we're going to do trace again, menu, number 5, and number 1, graph trace. It once again starts here at the y-intercept, so I'm going to go left to get to this root, this 0. Notice it isn't a whole number. It's actually at -0.5. Otherwise known as -1/2. Now I'm going to go to the right and keep going until I get to the other 0, which is at 3. So I'm going to write those down. X equals -1/2 and x equals 3. Those were my two solutions. Okay. So those are our x-intercepts, but remember another word for them is solutions. And you'll notice these notes, guys, were the same notes that you did earlier in the week, 8.2. These are the exact same problems. But instead of factoring them, we are figuring out how to find the solutions graphically on our calculators. Okay? But it's still important to know how to factor because you will need to know how to do it for other math classes in the future. It's a very important concept. So now let's look at some word problems. Here we have a word problem where we have a rectangular trampoline that has area of 112 feet. The length is 6 feet greater than the width of the trampoline, and we want to know what is that width. And there's actually an equation for it. Lucky for us, they just gave us the equation. Super easy. So what is the width? That is what we are trying to find. So we're trying to find W. Instead of solving for X, like in all the other ones, we are solving for W. So we can still use the same strategy that we just did. Type it into our calculator. So I'm going to give you a moment, pause the video, type it into graph without the equal 0. If you had any issues with graphing it, maybe it's because you used W. Notice that our function says f of x, which means we have to use x when we're typing in graph. So just change all the w's to x's. And don't forget, don't put the equal 0 at the end. I'm going to hit enter. Notice that I do not see my entire graph. I only see this part of it. It is a parabola, not just a line. So let's go ahead and zoom. I want to make sure you know how to. Hit menu, go to number 4 for zoom, and then we're going to use zoom fit. It's all the way at the bottom, letter A. And notice I still don't see all of it, but I can go here to this -10 and maybe change it, double click on it. You can use the mouse pad on your calculator to double click. I'm going to change it to -20. Now I can see my entire graph much better, and we can use trace to find our roots. Menu, 5, 1. I'm going to go to the left to find the root on the left. It may take a moment because it's going a little slowly. -14. And now I have to go all the way back to the right to get the other one. So keep that in mind, -14 is one of the zeros. The other 0 is 8. So I'm going to write those down. One of my solutions, and remember we're solving for W, not really X. We got -14 and we got 8. Now, first of all, we're asking for the width. Can the trampoline have two different widths? No, it can't. It can only have one width. And the most important thing we can note here is that it can't have a negative width. So that means our width must be 8. In this case, 8 feet. So I'm putting the unit on there. Make sure with real world we remember we shouldn't have negatives. So let's go ahead and look at number 2, which is very similar. We have an auditorium that has rows and it has seats. This is the equation that represents that, keeping in mind that x represents the number of rows, okay? And so if I were to make a table of this, for instance, x represents the number of rows and y would represent the number of seats, okay? We know there are 416 seats, and we want to know how many rows would that be. So all we have to do right now is to type our equation into graph like we did before, but look at the table. So go ahead and take a moment to type it in. Okay guys, I've already graphed it. You can see the equation here, but like I said, the important part is the table. So if you go to Control T, you can see the X's, remember, represent the number of rows, and the Y's represent how many seats are in those rows. Since I cannot have negative seats, I am not going to go up here. I can't have negative rows or negative seats, so I'm going to keep moving forward, downward. So if there are 4 rows, there are 8 seats total. There are 5 rows, there are 20 seats, etc. So now we're going down until we see 416 seats. There we go. So it takes 16 rows to have that many seats. Okay, 16 rows will give us 416 seats. Okay. So keep in mind, always positive numbers. You can look at the table to help you find answers as well if you need to. Okay, work on the practice. Let your teacher know if you have any questions. Raise your hand and they will come right to you. Remember guys, come in for tutoring if you're really struggling. Have a good day. Bye.